Hey, this is Professor Lucine, and this is lecture 15. We are actually, after this week, we're halfway through the course, which is kind of incredible. Uh, Typically, I have a friend of mine, Tony Prospero from Marsh and McLean, would come in and talk about walking working surfaces, and what he does a lot of customer audits on this topic. And I mean, they've gone as far as to use I think it's called an ergonomer, to test the amount of slip or skid a type of flooring may have in order to help a customer. So let's go through his presentation, and then I have some additional information I'd like to share with you. So first, he calls walking a controlled fall, and I think that's kind of funny. And he gives examples of some of the things he read. Here he provides a little bit of information. Now we do know that the second most frequent cause of workplace death is slip, trips, and falls, tends to be from a height. There are different types of falls that are classified in workers' compensation. There's fall from height, fall same level, fall on stairs, and fall on ice. Those tend to be the main four. There are other forms as well, but those tend to be the top four types of falls that get work comp claims. And he shows here that 11% of work comp claims are due to same level slips and falls, and 13% of the claims. Most industry groups, slips and falls represent the highest or the second highest type of work comp claim. So it's usually, yeah, material handling. So good on you, Tony. Yep, right along with what we've been talking about in this class. I think I had this picture before when we were talking about the Oakley book, but here's a hierarchy of controls. If you can eliminate a slip, trip, and fall hazard, then there's really no reason to have it be part of your program. But here's the thing. The number one force in falls is gravity. And so unless you're, Superman, Spider-Man, or to a lesser extent Batman, or somehow able to work in outer space, it's difficult to do elimination. We can guard things. We can use like guardrails, or permanent coverages so that we don't like fall through holes and stuff, but they're kind of there. If somebody tries to break through, they can still get hurt. So we use a combination of things. Some railings, floor coverings, proper use of ladders, or when you have to work with two hands on a ladder, a scissor lift or a cherry picker. Administrative controls, we're training people, using signage to remind them the right things to do. And then personal protective equipment would be more of like a shoe that has some slip resistance to it. Maybe the use of gloves when you're climbing, maybe it'll give you better grip. That's the type of things that we're able to do. And if you remember, I believe slip, trips, and falls, when we looked at it over time from the Bureau of Labor Statistics, we're kind of coming up a little bit, if I remember correctly. I think there was a down, up, down, or something like that. So no net decrease. So it talks a little bit about ergonomics, and what's interesting is physiology, capability, the way to overexert does contribute to slips, trips, and falls. And sometimes we'll have sprained wrist or broken fingers or broken wrist, back contusions, other body parts contusion as the result of the causeless fall. So it's the contact with the ground that does the damage, which is kind of an interesting combination of struck by, caught in, and also ergonomic type stuff. So what he talks about here is all the different places where you can get a hold or a feel for what your employer's risk is or what their potential is for slip, trip, and fall injuries. Here he's providing 5 years of loss run data, which is workers' compensation data, just showing that slip, trip, and fall at this particular facility was definitely number one. It was 28.7% of the claims and about 36% of the but then you go down, it's got fall from elevation. Why wouldn't that be under slip, trip, and fall? It was the most expensive, likely the most deadly as well. We talked about these things before. So the picture here at the bottom, that is how you measure sort of the resistance, the slip resistance of a flooring. And I think they have some consensus standards that if something becomes wet, or there's potential for ice or condensation, on a surface, is it too slippery? Therefore, what you can do is you can treat the surface with something that allows it to have more resistance. You may have seen work surfaces paint, with a paint that has like a grit in it. There are different types of surfacing. There may be a temporary rug or mat that gets put down that reduces that. Um, Things like proper maintenance of sidewalks outside of a building, so when you come in, you're not tracking in moisture, ice, things like that can also help. So now he's going through subpart D. Starts with 1910-22 general requirements, talks about housekeeping, and that does include snow removal. Make sure that you don't want something to become uneven, because actually when we walk, think about this when you're next time you're walking, how high off the ground does your foot go? When's the last time you kind of your foot hit the ground when you were walking? I mean, you've got like how many years experience walking? 19, 20, 21 years. Why does that happen once in a while, that the foot kind of skids on the ground and kind of you lose your balance? And the other idea is the difference between a trip and a slip. A trip is there's been something that has impeded you and your momentum carries you forward. When you slip, the extent of the foot or the leg moves outward and then you fall backwards. I don't know if he was going to say that or not. In 1910-23 talks about ladders. I was actually going to do a ladder demonstration because I've got two extension ladders. I believe one is a max 14 foot. The other one I believe is an 18 or 20 foot. So I use one for accessing gutters and roof. The other one is sort of lower level stuff like in my garage, and then I've got the typical A-frame. Did you know that ANSI sets up what is the max weight on those things, or the max acceptable weight on those things? And if you ever go to Home Depot, Menards, I forget the one we don't have around here, it's Lowe's, go visit the ladders and you'll see the sticker and the rating. And notice you probably won't see as many wood ladders, because wood ladders tend to become, over time, they damage or degrade faster. And so if you've got a wobbly ladder, you really got to take it out of service. And you don't tend to see the aluminum ones as much anymore because they're susceptible for becoming electrically charged. What's the word? Conductive if you're working with electricity. So there is a preference for the fiberglass. Here's some other options. I worked at a Home Depot before, and we had the mobile stand ladder where we move it, push down to lock it, and then we could go up it, and we had rails or whatever, and we use it to access the second or the third shelf. Yeah. So here's some examples of what not to do. You should never work above the second step. It's not designed to do that. Because you should always keep a three-point contact whenever you're on a ladder. And what that means is you should, I mean, when you're working on a ladder and you have to use two hands, and as long as it's lower to the ground, at least you can have both feet and lean forward and have your knees contact the ladder. If you have to stand straight out, you really shouldn't be using the ladder. So three-point contact, either both hands on a foot or both feet in one hand. Never work above the second ladder rung, so never go to the top. And usually there's stickers on the ladders to remind you. And then also always keep your center of mass within the two rails of the ladder. They call it the belt buckle rule. So your midsection should never go, because as you deviate, what you're doing is you're shifting the center of gravity of you on the ladder, and then it could tip should you move out. Always make sure that you're on a level, stable base, and because you also don't want the feet of the ladder to slip out. And finally, you should be at a 4-to-1 angle. So for every foot up a wall you're going to climb, you should be 1 foot away. So every 4, it's 1 away. And an A-frame ladder kind of naturally demonstrates what sort of angle that might be. And if you're using an extension ladder to reach a higher surface that you're going to actually climb onto, whether it's a roof or an elevated surface, your ladder should always extend 36 inches beyond that surface so you can climb all the way to the top and step off and still exhibit that three-point contact. And then if it's also a certain height, you're also supposed to secure the ladder to the structure in which you're climbing up, so that because that transition from on and off, that can get kind of wiggly, and you don't want it to tip over, especially with you on it. Under certain conditions, a worker would have to actually use fall protection if they're going to work. So in general industry, that height is 4 feet. In construction, it's 6 feet, unless you're doing iron work, in which I think you have 20 foot inside and like 20 or 30 feet outside. They've lobbied OSHA to get special considerations. It's dangerous for sure. So if you ever see a roofer, they should really be tied off unless they have some sort of temporary guardrail system. You can put up nets too, but people just don't use nets anymore. So, and that's the reason why I think the #1 most cited standard is falls. I'm sorry, working without fall protection because of roofing. It's really easy for an OSHA inspector to drive by a residential building, look, go up, took a picture, go up, get everybody down safely. Here's the citation. That's why it's #1. Pretty easy to cover. Second would be like scaffolding, not properly guarding and actually constructing the scaffolding. So like here's an open working surface here. It needs to have guardrails or some sort of tie-off that runs along the building where somebody could walk along. And so what Tony is showing here is the duty of fall protection using the roof edge protection, in which you can put up a barrier so that people don't get within 6 feet of the edge. Now, if their job requires them to be on the edge, then they have to actually need to be tied off. Which is to say, wear a harness, have a lanyard attached to an anchor point that's rated at minimum 5,000 pounds. So here are some examples. You can see by designated area. So you don't need fall protection when you're within this designated area. And give some definitions here. Here's an example of some permanent fencing. It can be both permanent and, so it can actually be put in place when you need it or actually set down. That's more of a look preference. What do they call that? Oh, Tony's referring to some new changes to Subpart I under personal fall arrest. We'll get to personal fall arrest, I believe, later. But he's talking about the different things here. Here are some different, so whoa, person looks like they're dangling from a broken scaffold transition scaffold there. Mobile scaffold, sorry, jeez. There's work positioning, that's when you're in a harness and you're kind of being held up. Those are typically used with like tree cutters. Travel restraints, yeah. So here he's showing ice on a parking lot because there had been a claim that somebody slipped and fell. Here's a tripping hazard, just running a line where people are going to be moving quite a bit. So housekeeping maintenance, reminding people what to do. If it's wintertime and it's currently snowing, there should be some sort of, as people enter a building, there should be quite a decent sized map there where they can like stomp their feet to at least get off some of the snow so they're not just tracking it all indoors. I know there's also a new device that it's temperature set so that when the temperature gets below freezing, it changes the color on the sign, and in doing so there's a message about, be careful, there may be ice here. Though you should be using salt and sand, conditions change in Wisconsin every 10 minutes. Talking about treatment, talking about footwear. Footwear, it should be very much the last resort for multiple reasons. It's expensive. And as people walk on them, they're going to wear away on whatever design you have on the bottom of the shoe, so it would have to be replaced. And here he's giving, some good stuff. So Tony is a great guy, always shares great stories and brings in great pictures. Now, as a follow-up, what I'd like to do is go through this. This is created by the Dairyland Power Cooperative. They did a really good job. I reviewed probably 12 different presentations. I shared a few as bonus on the Canvas site, but real quick. So they talk about the prevalence of slip, trips, and falls from a fatality perspective, and frequency. Oh, this is the same thing we use, but I think we had the 2019 numbers. But as you can see, number 2 and 3, both, one is fall from safe level, one is fall from lower level. Fall to lower level, sorry. Slip, trip, and fall. Slip, trip without a fall, so that they caught themselves. Still get an injury. These are the different heights the people have fallen and off of things. So this is from the national, this is from OSHA. So this reiterates the 4 foot or above must have fall protection. So either a guardrail or a personal fall arrest system. It talks about safety net systems. Nobody really uses it anymore because you have to verify that they could withstand a certain poundage fall. But when you do that, are you damaging the system? So they tend to use restraining systems, guarding rails, stuff like that. Okay, applies to all permanent places of employment. If not, you probably go to the construction. It's more extensive in construction for sure because they tend to be working at heights, especially open-sided surfaces. OSHA estimates the changes to Subpart D, which is fairly recent, like 2 to 3 years ago, will prevent 29 fatalities and 5,842 lost workday injuries every year. We could probably test that. Here are all the parts within Subpart D. We didn't really talk about powered platforms or vehicle-mounted elevating or rotating or man lifts simply because they kind of fell into, or we actually got a little bit of it when we covered the powered industrial trucks. We talked about cranes, overhead cranes, and slings in the previous lecture. So this, I'm glad I titled these together. They actually all naturally went together, and I'm glad I covered the other stuff first and then moved to this. It's because, you know, I think that it makes this more understandable. Which this topic is more important than the other two. The other two are somewhat unique, whereas this is an everyday thing. Showing some examples, things you need to fix, things you should be able to spot. And if you see something, don't just say, oh, that's a problem, you got to get it fixed. Probably put up a warning right away until it can get fixed. Getting into the ladders, proper use of ladders. And they've got a wood ladder there. Wouldn't recommend it. Should be fiberglass. Here it's talking about the same rules I had shared before. Has the extend beyond but 3 feet, I said 36 inches. And then the 4 to 1 rule. Maintain 3-point contact. I had talked about that. 2 hands, 1 foot, 2 feet, 1 hand. If you have to work at a height, make sure you can at least lean against the ladder as the 3rd contact point. But be prepared if you are to somehow get disoriented or lose your balance, that you're able, that you know to throw your tools and grab on right away. That's the self-protect. More on ladders and the warnings. It almost looks like the same picture that Tony provided. Step bolts, manhole steps. Wouldn't recommend these, though they cover it. People want to have a side rail they can grab onto or the rungs they grab onto. It's interesting that way. Now, there should be, for this manhole thing here, this, if you're going to be climbing up to this new start, this should be extended by 36 inches. If you have a cover that goes onto, when you pull the cover off, there should be something that you can attach to or back up so that there's something else to grab onto. So stairways, you know, there's certain rise and run requirements, and you want to make sure they're all uniform as well. Because if you have like 10 steps, but one of them is, let's say, the rise is 2 inches shorter or the run is 2 inches longer, people get into rhythms and expectations, and they'll tend to trip without realizing it. You don't always look at stairs when you're actually climbing up or down. Dock boards. We talked about powered industrial trucks. A dock board or a dock elevator is just meant for it to be the transition from the dock itself to the trailer. Talks a little bit about scaffolds. That's a class in itself. And it tends to be more related to construction, which is why I'm not going to spend much time at all talking about it. There are some interesting videos and pictures online of poorly designed scaffolds that fall over. I believe there was recently a scaffold that crumbled or broke in New York City, and I think there were some deaths associated with that. Duty for fall protection. Yeah, I was talking about hoists. We had talked about those, floor holes, ladder floor holes. So what's interesting now, and a consultant had called me, if you have a permanent ladder that goes from one surface to another, when you get to the top, do you have to have a gate that you close behind you? Yes, you do. How should that gate be mounted? To the permanent railing and not the ladder, because the ladders aren't designed to be able to have it attached to it. That's what we had worked out together. Here there are chains, but a spring-loaded gate that feels closed, so you climb up, you just push and get out and it closes behind you, is the better design. But you could use chains if you wanted to. A lot of construction sites use these temporary, they design their own guardrail systems. There are height requirements, so there needs to be a toe kick, there needs to be a mid rail, and there needs to be a top rail. The top rail needs to be minimum 200 pounds force horizontally on it. I don't recommend you being the one push, but it needs to be able to withstand 200 pounds. It's a basic idea. I do know that there are some companies now that are creating more modular guardings for working at heights. Helmerson out of the Twin Cities tends to be the leader right now. Her name's Deborah, and I've known her for like 25 years. It's a good product. I definitely recommend it. I know they used it on the when they were building the Vikings Stadium. Fixed ladder information. This isn't stuff I want you to memorize, but you kind of see here they've got designation of the height for like railings. So if you have at least 3 treads and 4 risers, you gotta have handrails. Here's some other handrail requirements. 2-sided, 1-sided, open. So something to know if you have to inspect these things. Those look really nice. Talking about roofs now, I think Tony did a really good job about designating what's needed for those. Oh, this is what I described. So the standard rail, and as you can see, the spring-loaded gate is attached to the railing itself and not the ladder. So if you see it attached to the ladder, that's actually a violation. Now it's interesting, yeah, it extends 36 inches, the side rails there. Talks about the tube, talks about the railing, talks about the toe board. That's funny, because I just brought that stuff up. Safety netting, not typically used, not recommended. Minimum braking strength of 200 pounds, so, but you're supposed to verify it. I wouldn't recommend it. Not recommended. It's better to put up rails. Or a personal fall arrest system that has a cable that can run around the outside so that people can hook onto it and move about. And sometimes what they'll do is they'll actually have a self-retracting lanyard, so that it gives the worker even more mobility. And if they were to fall, then it quick locks and then they won't fall very far. You want minimal fall, because just like a 3-foot fall and slamming into something, you're going to get hurt. And then you have to have a rescue plan as well, because you don't want them dangling there for long. All the pressure is being put into the leg straps, and yeah, you got to get them down pretty quickly, because it's going to cut off circulation and could have other problems. Talks about training requirements. Definitely got to train people who are going to be working at heights. Again, you can't eliminate it. You can only really protect against it. Gives us OSHA timeline, hazard recognition. There are more than a few great photos and videos online. Great job. They did a really good job in putting that together. Here's OSHA's final rule on the Subpart D. I provided this to you, and they really just kind of update. There's a lot more pictures on the in the standard than they had before, and so people can kind of visualize what needs to be done. Training requirements, timeline, yeah, all really good stuff. And then one extra thing, and this aligns with what we had talked about early in the semester. This is from United Heartland. If you remember, I referred to Jim Jones. We talked about musculoskeletal disorders and ergonomics. So this is from his group, United Heartland. And this is like an accident investigation for a slip, trip, fall. This is really good. See? So you can identify which body parts were hurt. You can check the box. Investigation, so cause of accident. I think they want you to consider different things. Look beyond the worker. What corrective actions can be taken, and other information as well. Look at this. This is free. I gave you both a link to the website and also this write-up. And what can you do when someone slips and falls? Because likely somebody else will slip and fall if you don't do anything. Very cool. Cool stuff. I think the last thing I want to do, so here's everything I've given you. So we went through these two presentations. They're in PDF. I've got the two bonus here that are actually in PowerPoint. One is very generic and it's long. You don't have to look at that. This one is for construction. So if you're interested in construction or working in construction, this one is dedicated to it. It's pretty good. It's more all about different types of personal fall arrest systems or setting up railings and stuff like that. Here is final rule in Subpart D. We just looked at that. Here's the OSHA website where it talks about the changes. Here is what we just looked at from United Heartland. This is the link to that website. And then I've got this great, this is really great. So this was done, this is Pennsylvania OSHA consultation, I believe. It's a 12.5-minute video. It's great. They really break things down. They've got cool pictures. So definitely watch this along with the lecture I had here. So we're at about 26 minutes. I'm going to cut it off there. So congratulations. We're halfway done with the course so far.